Here at HML, as far as the process of the arsenic testing, we're using EPA method 200.9. It's being tested on a graphite furnace atomic absorption. Set by the EPA, they have set a level of 10 parts per billion, or you can say it as 0.01 parts per million or milligrams per liter. I did a study earlier this month. At the time, I had 58 total, basically drinking water samples. Out of those 58, 9 of those samples were above that limit of 0.01. I had above 0.005 ppm, which would be half of the limit. I had 22 of those samples, and basically I have a detection limit of 0.001. It's the lowest that we report out for arsenic. Out of those, 39 were even just above detection. So arsenic is something that is pretty prevalent in drinking water.
Arsenic can enter the groundwater supply in a variety of ways. So it can leach into groundwater if it is coming from a site where there's hazardous waste deposits, if it's surrounded in an aquifer that has shale deposits that are high in arsenic or high in arsenopyrite, which is a naturally occurring arsenic-bearing rock. We can also see arsenic enter groundwater from sites that had lead and copper smelting. That's usually associated with treatment of wood, and arsenic is a part of that because it's used to treat wood compounds to make them last longer under weathering conditions when they're outside. Arsenic has several health effects on the human body, especially for some of our vital organs like the lungs or your skin. It's associated with lung and skin cancer. It is associated with breathing disorders, and long-term exposure of rates above 10 micrograms per liter in drinking water is associated with quite a few issues.
In my opinion, arsenic, as far as being in our drinking water, is something that we pretty much rely on others to check. Since I haven't seen any arsenic poisonings that I know of in the emergency room, it's really not something that we put on our radar as something to look for. Although when people are ill and it's been a long time, a process of them trying to figure out what could be causing them to be sick, sometimes toxic exposures similar to arsenic are something that we have in the back of our minds to look for.
Now, as far as your drinking water, if you're using a reverse osmosis system, that will basically take all the arsenic out. I mean, as far as the bottled water goes, it's probably fine. They did a study, they actually were testing Fiji water, and they just said it was just barely under the limit. But yeah, as long as you're drinking water, if you have a reverse osmosis, I mean, it will take that out of there.
In my opinion, arsenic in drinking water is an issue in the areas where we have identified it as an issue. Outside of those areas, as long as arsenic is under 10 micrograms per liter in terms of water samples taken, measured, and analyzed in a known lab, then you're not to be concerned with it. But we've identified most of the areas of concern for arsenic contamination, and those are under study.
People should be aware that arsenic is an issue with drinking water, and yeah, I mean, they should be testing that.
If you have something that's making you feel bad or sick, but it doesn't seem to be a life-threatening illness, getting into a primary care or family doctor is the best plan.
Some concluding thoughts I'd like to leave with the audience are how important science is for understanding the level of contamination, what contaminants are there, how they got there, what threat, if any, they pose to the public. We really have to support our science programs across this great nation in order to make sure that we have that information available.